Hello everyone and good day. So in this video I will show you how to plot earthquake focal mechanisms, also known as beachball diagrams. So we will split this tutorial into two parts. First part will be how to extract the focal mechanism data. So let's start where to get this focal mechanism data. So these focal mechanisms describe the fault orientation and slip direction during an earthquake. So usually it's represented by a strike or a dip or a rake values. So the first step on this will be choosing a particular data source or database. There are several global databases that provide this focal mechanism solution. So, and most commonly are the USGS earthquake catalog. There is International Seismological Center, ISC, global CMT project, and some other countries like New Zealand or or Australia. They have their specific regional seismic agencies. So but in this tutorial I will demonstrate using the International Seismological Center, but the workflow is almost more or less similar to for other sources too. Depends on your particular project or your particular need for the research. So let's start with how to choose this data source. So you can start by opening any browser. As we said, we will use the ISC. We will use the ISC earthquake catalog. Sorry for the typo, but this will be the link, and you will open a you'll get an interface something similar like this. You'll select a particular database. In this case we need the IC bulletin and CSV formatted catalog. How you'll search your region accordingly to your particular research area, the extent. So like in this tutorial we will use area from the Java Trench through laterally through Papua New Guinea to Solomon Islands, which the extent should be around for the bottom latitude, because we need latitudes, we'll use the y values, and for the longitude we'll use the x values. So the bottom latitude will be the minimum y, which is around minus 14.8 and the top latitude, which is the maximum y value, which will be about 8.2, and the left longitude, which will be the minimum x value, 94.3, to the right longitude is the maximum x value, which is about 173.5. So this is just to define our area of interest, and then there is a time period here for how the event of how long, a decade, months, or years. So we'll see. Let's say we are starting from 1976, January 1st January to December 2025. Let's say December 31st 2025. Let's say, and then some additional parameters. Depends on how you want to filter your data again. So let's say we're starting with the minimum depth of 0 to 40 kilometer. We need this the shallow events, and the minimum magnitude, maybe we can start with the magnitude of 6.5 to whatever, and then magnitude type and everything depends on, again, on a particular interest. So you'll press output event catalog, and a data set will appear here after a few seconds. Still running. Excuse me. Well, it takes long according to the amount of events you'll get. So as we see here, is a lot of events, much about 835 events. So this is basically what you will get, something like this. And there is a KML file that you can download and try to display first through Google Earth and check your area. And we are interested more in this data so that we can use to plot. But first, let's see maybe how this KML, is it your particular region, of your particular region, is it correct that you're getting the data from that particular region? So let's see through Google Earth first. Yes, so as I said, we start through the Java Trench here, through Papua Guinea to the Solomon Islands here. So yeah, we will go through, and but what we need actually is this data. So you will copy this all throughout excuse me, you'll copy this to the end of wherever your data finishes. You'll see this stop sign, and you will copy this data, and what you will need is a notepad. You'll need a notepad and then paste them. So I already have a sample data sets for you. You'll copy them somewhere like this, and this is what we downloaded, what we copied from the website. So after having this, you'll save it to any particular directory that you want, and then now we will go through Excel. Open Microsoft Excel. After opening the Excel, you need to insert the data that you copied from the website, which we saved it in a text data type format. So I reduced the number of events because it's just for demonstration purpose. So you will load your data like this in Excel, and you'll see a lot of parameters here, as you can see, but there are only certain parameters that we need. There are certain required parameters that we need for the tool to run through ArcGIS Pro later on. So what we need types like latitude, longitude, we need depth, we need the magnitude of the event, and strike and slip components of a particular event. So you'll clear some rows, delete, and just clear some of the unnecessary data that we don't need, and you'll get something like this, which is event ID, latitude, longitude, depth, magnitude, strike, dip, and rake. And then you make sure these are the minimum parameters that you have, and once you finish cleaning and everything, make sure you don't have any missing strike or dip. Like there's no event which have like an empty space. Let's say there is an empty cell, because later on when we run the tool in the ArcGIS Pro, the tool will develop through a Python code, which will make it which will cause an error and the tool to fail processing or generating this Beachball. So make sure those with empty cells, make sure you are deleting them, cleaning them. So after cleaning the data, you ensure already the coordinate system are the same as your base map later you're gonna use, and then this should be your final table. It looks something like this. And then yeah, that's it for part 1. Now that we have clean focal mechanism data, stay tuned for the part 2 and how we can use this data to plot beach balls in ArcGIS Pro. Thank you so much. See you in part 2.